Alright, hey guys, Pogo here, and welcome to day one of the Game Jam. I'm going to start this out with just a little explanation of what we're going to be doing, and just all of the important information about it. I'm sorry about the fan. I'll try to do something about it, but I am doing a lot of things at one time. Alright, so basically what we're going to be doing is, over the next 5 days, I'm going to be working on a little RPG game. It's basically going to be something similar to Pokemon, if you've ever played it, where you can walk around on a two-dimensional field. You can walk around the different tiles and interact with other players. Now, given that we only have 5 days and around an hour a day, the game is going to turn out as more of like a framework or a skeleton, or, you know, it's a framework of an actual game. And then you can actually take it and adapt it. We'll basically get it where you can create maps and render the maps and have a player that can walk around, and of course other important things, you know, tile-based event system where moving to a certain tile or interacting with a certain tile will cause a certain thing to happen, and then some other things. Now, I do have the chat open on my second monitor, so if you have any questions or comments or anything, I am currently looking at the chat right now, and I will be happy to respond. Also note that there is a little bit of a delay, so I'm speaking right now, but there's, you know, a couple seconds of a delay in between speaking. Alright, so let's go ahead and get started. Now, first, one thing to note is if you go ahead and take a look right here, I have set up a GitHub wiki. It's a GitHub page, rather. You can head over to the GitHub page, and this is where all the code's going to be. And throughout the video, I'm going to be pushing code onto here so that you can basically follow along. Now, all of the images and code will be here. So if you go ahead to the repository right now, you can access the code and the graphics throughout the video. If you are on the live page right now and you go towards the top and click more event details, you'll get a link, but it's just github.com/pogo629dev, and I've decided to name the project for now RPG29, just a basic RPG game. So GitHub is right here, and I will be posting to the GitHub repository throughout the video so you guys can follow along. Now, as I said, we're going to be starting from scratch, so if we go ahead and take a look in my IntelliJ window right here, you'll see that I don't have any code. I already have it all set up with Git so I can push it, but there's no actual code here yet. So we're going to go ahead and get started. Now, I am using IntelliJ for this just because I find it to be easier with the auto-completion and, you know, other features that it has that I really like. So you could, obviously the code will work in any IDE, but I'm going to be using IntelliJ. So let's go ahead and first we want to go ahead and create our package. We'll call me.pogo629dev.rpg29. And, alright, so we have our package, and we're just going to go ahead and make a main class. This will just be the main class that contains the public static void main. And then we're going to go ahead and do public static void main string array args, and then we will have our main method in there, which we will get back to soon. Now, there are a lot of different components that will go into this, but I think that for now, let's go ahead and start out with the window. Let's get a window to show up. We can get our window set up and then our panel set up where everything's going to be displayed. Then we can work on, you know, tile sheet, loading in the tile sheet, and then maps, and then eventually we'll get it to actually render the map onto the screen. So I'm going to go ahead and make a new sub package, which I'm going to call GUI. So this is going to contain all of our GUI components, and then we're going to go ahead and make a class called frame. This is basically going to be the frame class, and it is going to extend JFrame. Now, one thing that I forgot to mention that's very important is this game is going to be written in Swing, which is very different than, you know, Minecraft or any other thing that I've ever showed before. I do have a lot of experience in Swing, and I enjoy using it a lot. It's not really meant for games, but it actually works very well with games, so that's what I'm going to be using for this particular game. I'm going to try to do my best to explain it, but if you get confused at all, then make sure to, of course, let me know. Alright, so the first thing that we're going to do, and this might be temporary, but we're going to need to provide access to the frame from anywhere, because the frame is going to be the frame itself, but it's also going to contain the GUI, and the GUI, or like the actual thing that you see, is very important to be accessed by anywhere for, you know, controlling what you see. So we're going to go ahead and use the singleton pattern for this class, and again, I might change this in the future, but I think for now we're going to use the singleton pattern. Basically what a singleton is you take a class and you say you can only ever have one instance of this class, and I'm providing that one instance. I have done this before if you watch my videos and some of them, but let's just go ahead and do this. So we have our private frame. We're basically just making an empty constructor that's private, so it can't be instantiated anywhere except for in the frame class. We don't want to have, you know, 500 different frames. We want to have exactly one, and we only want the ability to have one. We are going to go ahead and make our private static final frame instance is equal to new frame. And what we're doing now is we're actually instantiating the frame. This is going to be the only instance of frame. Since you can only instantiate it inside of this class, we're going to make one of them. And it's going to be static, so that you can do public static frame get instance, and then we're going to return instance. So what we've done here is we now have a way to access, we now have a way to access the frame from any class that we want, and that's going to be very important. Now, the next thing that we're going to do is let's go ahead and create the GUI class. This GUI class basically represents the actual thing that you see. The frame holds what you're looking at, but the GUI is where you actually, you know, see all of the stuff. So we're going to have our GUI class, which is going to extend JPanel, because this is not a frame. We already have our frame. This is the JPanel, which is basically just a panel that can contain stuff that we need. So we have that set up. And now inside of frame, we actually need a private GUI called GUI, because we need to be able to have an instance of that GUI. Now, inside of this constructor, there are actually a couple of different things that we have to do. First, we need to say GUI is equal to new GUI, and then we need to add GUI. When I call add GUI, and I pass it GUI, it's basically adding this GUI component, so anything that shows up there is now going to show up on the frame. Then there are just a couple of other little things that we have to do. First, we want to do super RPG 29. What we're doing is this is basically, we're just setting the title of the frame to say RPG 29, like this is the title here. We want it to say RPG 29, that's just using a super constructor, not terribly important. Then there are a couple of other things that we need to do. We need to do set size to, I believe we wanted to do 640 by 500. I think that's the correct size, but we might change it later. That's basically setting the size of the frame to what we need it to do. Then we're going to do set default close operation to window constants dot exit on close. So what that means is when I press that X button on the window, it's going to exit the application, because if I didn't do that, then the window would go away, but the application would still be sitting in your dock, and then you would have to right-click it and quit it, which you, of course, don't want to do. We need to go ahead and do set resizable false. For now, we're not going to make it resizable, because that would mess up you know, a lot of the logic, like rendering everything and the movement and all of those different things. To respond to the question about Eclipse, I'm not using Eclipse because I personally find that IntelliJ is it's just easier to use. It has more features, and it's just like, you know, it has built-in Git support. So as I push the code that I'm writing, I can just click that one button right there, and then I can easily push the code up, and it's just a lot easier, and it's going to make the coding go a lot faster, so we can do more things. Finally, there's just two more things that we want to do. We want to say set location relative to null. This little trick is basically going to center the this is basically going to center the window in your display. If I didn't have that, it would go up here in the top left, but we want to center it. The reason why I'm using 640 by 500 and not 640 by 480 is because I have actually done a little bit of experimentation with you know, a similar concept of the RPG game, and when I went to go ahead and render the tiles, the size of the tiles, I think they were 32 by 32, and if I made it 640 by 480, it would cut off that last row of tiles, so I needed to make it 640 by 500 in order to have enough room for all of the tiles to show up. So that's why I'm doing that. Normally I would do 640 by 480. Finally, we want to go ahead and do set visible true. Basically, we're just, of course, setting the window to be visible. And then the last thing that we need to do is we need to say public GUI get GUI return GUI. So now we can access the frame with the singleton, but we can also use it to access the GUI, so that when we go to change the stuff in there, we can. Let's go ahead and write the outlining of the GUI class. We're of course not going to be doing any of the rendering yet, because we need to implement the tile sheet parsing and all of those different things like that. So let's go ahead and first of all, we can go ahead and make our GUI protected GUI constructor, because GUI is only going to be instantiated one time, and that's inside of frame. We're not making it a singleton because you don't need to have singletons for everything. It can get very confusing, but I'm making it protected so you can only access it in the GUI class, and because we don't want, you know, it to be instantiated anywhere else. So inside of here, we just need to do a couple of things right now. You know what, we don't need to do anything in the constructor yet. Eventually we will actually add stuff to it, but we're going to just leave it there for now. Next, we need to go ahead and make a public void paint component graphics G, and then we're going to go ahead and do at override. Now basically, and import graphics. Okay, what this is doing is JPanel has a method in it called paint component. That's called whenever I want to draw something to the screen. So inside of here, this is where we're going to be drawing the map, pretty much. So we're going to implement that once we get the tile sheet parsing and the map parsing. And then we're going to have a loop that will continue to call paint component so that it will keep updating the map as, you know, the player moves and different things like that. So this method is automatically called when I call a different method, and we'll get into that soon, but this is where the map is going to be drawn, and that's all that's really important right now. And we're going to go ahead and leave it at this for now. There are going to be plenty of other things that we're going to add in here, but for now, we're going to leave it at that. So let's go ahead and start the first major thing. First, I'll go ahead and say, let's just go ahead and show you this. If I go ahead and say frame.getInstance, and let's go ahead and run it so I can show you, just configure the application to run. So we want our main class, and I'm going to call this RPG29. So if we go ahead and run the application, just give it 1 second to show up. It's first time running, so it'll take a second. then you'll see that we now have a window. This window is 640 by 500. I believe that's what I used. It can't be resized. It was centered. It was moved to the center of the screen. It does have the title, and if I press X on it, it does disappear. So we did get the frame, and you can't see it, but the GUI is there. So when we go to draw the map will show up. So that's what we have so far. I'm going to go ahead and push this. There wasn't too much work done, but we're going to say frame created. And I'm going to go ahead and push this to the wiki, or the GitHub page, so that you guys can grab it. I don't want to get too far behind, and now it should be up there if we give it a second. Oh, it didn't work. Oh, I see. I'm not authorized. Alright, let me just do it in SmartGit, I guess. I'm just gonna... Let me just quickly do this. It wasn't letting me push it because I'm logged into the wrong account. So I'm just going to use a different program to do it. So here's RPG29. Let's just go ahead and ignore all of these things that we don't need. Class files. Ignore all of that. We want to ignore these, but now the SRC should show up. It's not working. Alright, that's fine. Alright, so looks like this isn't working. Let me just check in the settings, and then we should be okay. Just going ahead and going to push this up to Git version control. There we go. GitHub. And I was just logged into the wrong accounts. Let's do, see if that works. Try that. Okay. Now I think we should be good. Let's try pushing it again. Or I guess we need to go over to here. And now we need to go ahead and push this up to the remote. Which one of these buttons will do that? Sorry about this, guys. I guess I didn't really test pushing before I began. Let's just see if we can... Alright. Now this should work this time. Still didn't work. Alright. I'm not going to spend any more time worrying about Git right now. I will push it after the video once I figure out exactly what's wrong with it, but for now I'm not going to push it. So I'm not going to waste any more time with that. So let's go ahead and continue, and we're going to write the tile sheet parser. Basically what we're going to do is we're going to write a class which represents a tile sheet, and then it will be able to load in an image, find the specific tiles in the image, and then it will be able to, you know, have an easy way to get all of the images. Then we're going to write, you know, something that will allow you to access the tiles by name, and then we're going to, you know, do a couple of other things with that. So let's go ahead and make a new package, and we're going to call this tile. And then let's go ahead and make a class called tile sheet. So this class is basically going to represent a tile sheet, and we're going to have multiple tile sheets. We're going to have one for the environment, what the map is actually made of, and then we're going to have one for the like, you know, the player is going to also use a tile sheet, and we're going to have the different directions of the player on the tile sheet. Now, before we begin, there are a couple of other things that we need to do. We need to, first of all, in SRC, we need to create a new package called res. That's for resources, and that's where we're going to be storing all of the, you know, images and anything that we use as a resource. So inside of the res folder, we're going to go ahead and make, we can go ahead to tile sheet and grab this tile sheet that I have and paste it in. Now this tile sheet will be available on GitHub, but I'll show it to you right now. This is the tile sheet. It was made for me by a friend for something else, but I'm going to use it for this. It basically contains your standard grass. It has, you know, 2 rivers, has different parts of a tree, has some coffins. I guess I might have been trying to do something of a scary game. It also has a bunch of different fence components. It has some path things, and I think that these are chests, but I'm not completely sure. So each of these tiles is 32 by 32. So we're going to go ahead and, you know, that's how we're going to be parsing them. So we also need to go ahead and make yet another class called constants. Now this constants class is going to contain basically just a bunch of things that will remain constant throughout the entire application, and it'll allow us to easily change them. So for example, right now we're going to do public static final int tile width is 32, tile height is 32. So what we're doing here is we're basically saying this is never going to change. It's always going to be the same in this game. And so if I ever, let's say I decide to get a different tile sheet where the tiles are a different size, instead of finding every single instance of the number 32 and changing it to, you know, 48, I can just change it once here, and then it'll automatically change it everywhere else. It's good practice to use something like this, so that's what we're going to be doing. And, alright, that should be good. 32 by 32. Alright, so we have that set up. Let's go ahead, and now we have our resources folder with the environment.png. That's just the environment that we have. And we need to go ahead and make a another utility. I'm going to put this in the util package. And I might as well throw constants in there just to keep it separate. We're going to make this one called resource util. This is basically going to be an easy way to access anything in that resources folder. And then it's also going to have some other nice methods for, you know, parsing or resizing an image or getting an image or anything like that. So the first thing that we're going to do is we're going to have a private class class. What we're going to do is we need to have an actual class, because when we go to get the resources, we need to have like a class that we're using, like this main class, and then we can use that to kind of like look around and get resources from things nearby. That's the best way to think about it. You don't need to worry about the question mark. That's called a wildcard. It's just basically saying it can be in any class we want, because it doesn't really matter here. As far as the comment about 720p, I have this streaming in all qualities: HD, high, medium, low, and mobile. That's like, you know, a lot of different qualities, so it might be struggling and be in the lower quality. When I do upload this to YouTube after the stream, it will be in full HD quality, and you don't need to worry about that. I do have Ethernet plugged in, but there isn't really too much I can do to help it right now. So we have our class right here, and this one is going to be another singleton, or yes, this one's going to have to be another singleton. Private resource until that private static final resource util instance is equal to new resource util public static final resource util get instance will return instance. So we're doing there we go. Okay, so now we are and I guess it's telling me not to use final, but so now we have this resource util, which is going to have this class that we're going to use for getting the resources, and it's also a singleton because we have because you know you just want to be able to access it anywhere to do different things. Now we do need to have a public void setup that takes the class and then say this dot class is equal to class, because we need to actually have this class right here. So in the main, we need to first say resource util dot get instance dot setup this. Now you'll notice that it's not going to work because we're in a static method. So we need to actually make a private main constructor and then say new main like that, and it's going to be get class. Now, just to quickly explain what this is doing, basically, we have, by doing this, this main, anything in here is in a non-static context. Because when I try to use get class, I can't use get class if I'm in something that's static. So by moving this to a non-static instance, I can use get class, which I actually need. So, not terribly important, but we now have this set up so we can safely use any of the methods and they will work. So we're going to go ahead and write a couple of methods, and each method is basically going to build on the last method, and we're going to have a bunch of different methods that will be helpful to us. So the first thing we're going to say is public URL get resource, and then this is going to take a string path, and URL is going to be java.net.url, and we're going to say return class.getResource for path. And so that's basically, I don't know if we're going to use that directly outside of, hang on one second, okay. I don't know if we're going to be using this directly outside of this class, but it's still important to be able to get it, because we're going to write a bunch of utility methods for getting images, and that's what really is important. Then we need our public input stream get resource as stream string path return class.get resource as stream for path. Now, one other important thing that I forgot to do is it's going to be in the resources folder, so we need to make sure that we specify that we're in the resources folder and then the path. So if I wanted to get environment.png, I could say get resource, and the path I would pass it would be environment.png. Then it would know to go inside of the resources folder and then find environment.png. So these two classes are kind of like just wrappers for, because you know it's just basically just calling get resource and get resources stream inside of this class, but we're just giving access to it for anything else that wants it. Now this is going to be the most important method. Public buffered image get buffered image string path. Now a buffered image in Java is basically just, it represents an image, and here we need to give back the image. So when we try to load, like, you know, the environment tile, like the environment tile sheet or the player tile sheet or anything like that, we need to have access to the image. So we're going to go ahead and surround this in a try and catch, and we're going to say in here return image.io.read. Then we're going to say get resource path.png. So what this is going to do is this image.io is just a utility class provided by Java, and we're reading, and we're calling this get resource method that we made, and then, so if the path, in this case, if I said get buffered image and I gave it environment, then it would return a buffered image that contains all of the data in this environment, because it automatically appends the PNG, because everything that I use is going to be in PNG format for alpha channel and all those important things. Then we need to go ahead and catch exception E, and we're just going to go ahead and say return null. Basically, if it fails to find the image or the image is corrupt, it would throw an exception, but we will never make that error because anytime we go to access this getBufferedImage method, we know that we're going to be using something that already exists. So we don't need to worry about, you know, any sort of debugging or whatever there. Now we need to go ahead and write a couple more methods. Public image icon getImage string path. We are then going to say return new image icon for getBufferedImage at path. So image icon is a class that is used by Swing for, it basically just represents an image. And basically we're just wrapping this buffered image inside of an image icon. But when we go to actually use this to like display the images, you know, if we go to display anything on the screen, then we need to have the image icon format, and this is just an easier way to do it. Then we can go ahead and say public image icon get image string path int width int height, and then we're going to say return resize image to get image path width and then height. And now we're just going to go ahead and write this resize image method, and then this will basically take the image and resize it to whatever we want. It's just an easier way to do it. So we're going to go ahead and say public image icon resize image string path, or actually in this case we're taking an actual image. Image int width int height, and we're not going to use image, we're just going to use image icon. And then we're going to say return new image icon. This is going to take image dot get image. This is going to give us an instance of the image class, or I think it's actually an interface. Then we need to say get scaled instance. This is going to take the width, height, and then hints. I'm not completely sure what that does, but just set it to 0 and then you'll be good. So that should be all of the important methods that we need in the resource utility for, you know, accessing our images. So next we're going to go back to our tile or the tile sheet class that we made, and we're going to start working on it. Now that we can access the image, we can actually work on it. So we're going to go ahead and store, we're going to make a private final hash map point image icon tiles, and then we're also going to store a private final buffered image, and actually this is not going to be fine. What this is going to do, these two things are, first, this hash map of tiles, it's going to contain the point and then the image icon. So a point is basically just a class that takes an X and a Y. So, for example, if I gave it the point of 0, 0, then it would, what we're going to do is if I would be able to give it 0, 0, and then it would give me back the image icon that is corresponding at that location. So that's going to be for, you know, we're going to be able to access all of the files, or all of the individual tiles. So now we need to go ahead and make our constructor. Public tile sheet. We're going to take a string path, or actually we don't even need that. We just need a string name. So the name will be like, you know, environment.png. So then we're going to go ahead and say try image is equal to resource util dot get instance dot get buffered image for name. So if I give this you know, so let's say environment as the name, then it would return the buffered image of environment.png. And that's what we want to do. Now, we're going to next figure out the number of X tiles and the number of Y tiles, because, we'll have multiple. We don't want to say this tile sheet is to be exactly this big by exactly this big, so we're going to figure out exactly how many tiles are in it. We're going to say int X tiles is equal to image.getWidth divided by constants.tilewidth, I believe, and then int Y tiles is equal to image.getHeight divided by constants.tileHeight. So basically we're just saying we're getting the width and then we're dividing it by, in this case it would be 32. So if we had something that was 64, if the width was 64, we would know that there are 2 X tiles. So that's just getting that. Then we're going to go ahead and say for int X is equal to 0, X is less than X tiles, not I. X is less than X tiles, X plus plus, and then we're going to go ahead and say for int Y is equal to 0, Y is less than Y tiles, Y plus plus. So we have a nested for loop right here that's basically going through each X tile, for each X tile, and then for each Y tile. Now inside of here, we're going to go ahead and say buffered image, tile image. This is the individual tile is equal to new buffered image, and this is going to take constants.tilewidth, constants.tileheight, and then it's going to take buffered image dot type int argb. So what we're doing is we're creating a new buffered image. This is just an empty image right now. We're saying that this is how wide it is, this is how tall it is, and then this is the type of the image. We're saying it has ARGB, which stands for alpha, red, green, blue. So it can contain, if I just said RGB, then it wouldn't be able to have any of that clear. So if you had something that didn't take up, like for example, this tree, the corner of the tree, if that was just RGB, that corner would appear to be white. But since we enable alpha, the corner of the tree will appear to be whatever is below it. So we need to make sure that it is in ARGB. Then we need to go ahead and say tileImage.setRGB to 0 and 0. It's taking the X and the Y, so we're just setting it to be 0. And we're actually going to be using this longer one right here. This is going to be a long one. Okay. 0, 0, constants.tilewidth, constants.tileheight, then image.getRGB for X times constants.tilewidth, Y times constants.tileheight, constants.tilewidth, constants.tileheight, and then we're going to say null 0 constants dot, oh sorry, this is actually inside of here, null 0 constants dot tile width, and then outside of that should be 0 and then constants dot tile width. Okay, first let's go ahead and format that. Now, in case you couldn't already tell, I figured that code out before I started, and so I did not make that up on the spot. I wish I was that good. I wish I were that good, but not quite. So let's go ahead, and that should work. Now, for whatever reason, I put the wrong thing somewhere, and it doesn't, then I will, of course, fix it. But we're not getting any errors there, so I guess it did work, and that's just nice and formatted for you. Then, we're almost done. First, I forgot to say tiles is equal to new hash map, like that. And I don't know why it's still giving me that error. I am instantiating it. So we should be okay there. Now, finally, after we do this crazy long set RGB call, we need to do tiles.put new point xy new image icon tile image. So what we're doing is this hash map, which stores each point and then each image icon. So we're giving it, it's like the first time it runs, x will be 0, y will be 0. It'll get the first, 32 by 32 pixels. It'll read them into this tile image, and then we're storing 0, 0, and corresponding to that is the tile image at from 0, 0 to 32, 32. Pixelaborate, I am not ignoring the chat, but I know better than to respond to you in particular. So, yeah. We just need to have our catch. We need to catch the exception, because when we do stuff like get buffer, or there's something in here that will give you an error, I believe. So we need to surround it in a try and catch. And then we're actually going to just call it ignored, because nothing's going to go wrong in there. If it does, then we'll fix it, and then we don't need to worry about other people using it and then possibly using it wrong. Then we just need to have public image icon get tile for int x, int y, and then we're just going to say return tiles.get for new point x comma y. So what we're doing is, if I want to get access to like the tile at let's say 0, 0, I could pass 0, 0, then it would put in 0, 0, and then it would give out the tile at that position. So we have that right there. So we have our get tile method, and I believe that's all that we're ever going to need for this particular tile sheet class. Next thing that we're going to do is we're going to create an enumerator, or an enum, or an enum, however you want to, I think it's enum for enumerator, and we're going to call this tile. And what this is going to do is it's basically going to be an easy way to store all of the tiles in that environment tile sheet. So as you can see, we have all of these different tiles. We have the 6 parts of the tree, or 8 parts maybe, I don't know. We have all these different tiles. So this tile enumerator is basically going to give us an easy way to get each tile by its name or by its unique ID. So instead of typing everything out, and you'll see when we go to make the map parser, it'll make a little bit more sense. So this enumerator right here is what we're going to use to give the name to everything. Now the first thing that we need to do is we need to store some information in each enumerator. Now I haven't really done too much with enumerators in my videos, but basically an enumerator contains a bunch of constants, just a bunch of things that cannot change, and they can have constructors. You can't construct them outside of this class, and they're all predefined. You can't define any of them later, but you can construct them right here, and they can store data and have easy access to the data. And in this case, it's good to use an enumerator because this is just storing information about the tile, not like any actual tile-related things that we'll need. We will make, a location class later that will have more important things. So we're going to need to store a private string ID. This is going to be the ID. So for example, if we have the tree, and I might call it tree top left point or whatever, but I could make it TTLP so that I would have to type that instead of the whole long thing in order to be able to access it, and that's going to be important. Then we need to have a private image icon image and a private layer layer, and that's going to be important. Let's fix image icon. Let's go ahead and do that, and now we need to quickly just write another little enumerator called layer. Now layer, this is going to have to do with rendering the map, because what's going to happen is different things are going to have different layers. The ground would be the lowest layer, Then there would be a layer a little bit above that for things that go above the ground. Then it would be the player. Then it would be anything that goes above the player. So if you had, like, when they go behind the topmost part of the tree, it will go behind them. Now this is going to be incredibly simple. We just need to define 4 constants right here. We have above, on, entity, and below. So what these mean is above means it goes above the player. So when we go to render it, the player will be, this will be on top of the player and it will hide the player. This is for like the very end of the tree. So when they walk behind the tree, they will be hidden by the tree. On means it's at the same level as the player, and I believe that those might be the kind of things that would block them. So like the fences, for example, if it's on the same level, then it would be blocking them. Entity is not going to actually be used by the tile class, but that basically is the layer where entities are rendered. So they get rendered around where on is, but when we go ahead and write the method for rendering the tiles, that'll make a bit more sense. And then below, it goes below the player can move on top of it, and it's just below. So this is going to be important because each tile is going to have its own layer, and then when we go to render it, we're going to have that. Then we need to go ahead and write the constructor, private tile. It's going to take the string ID, int x, int y, layer. Then we're going to say this dot ID is equal to ID. This dot image is equal to, and we actually also need to do a private static final tile sheet environment is equal to new tile sheet environment. And what we're doing right here is we're instantiating this environment tile sheet, but the only place that we're going to use it is right here in this class. So by making it static, I'm sort of detaching it from the class, so it's not going to instantiate a new one every single time because that would be inefficient. But we're only going to be using environment in here, so I'm just instantiating it in here. Then we're going to say image is equal to environment.getTile for x and y. Finally, this dot layer is equal to layer. Why is this giving me an error? Oh, I see. Alright, it's illegal to access static member environment from enum constructor or instance initializer. Well, in that case, let's just go ahead and do a private tile sheet environment like that. And then we're going to just say if environment is equal to null, environment is equal to new tile sheet environment, and then now it'll work. So basically we're just storing this environment variable, and then if it's null it'll be instantiated. I might end up changing that. I'm not completely sure if that's going to work how I think it will, so I'll experiment with it a little bit and possibly change that. So now we can go ahead and get that, and then we just need to write a couple of getters so that we can easily access things. Now, one other thing is we want to write just one other constructor that does nothing, and then we're going to say ID is equal to E. This is just for the empty tile, or just the tile where nothing exists. We're going to have that constructor, and that's only going to be used by one thing. Then we need to go ahead and do a public static tile by ID string ID. What this is going to do is, remember, each tile has its own ID, so we need to be able to access it by the ID. So we're going to say for tile t tile.values if t.get ID, which we're going to do dot equals ID return t return null. So remember, this method is static, which means it can be accessed by anywhere. So if I'm giving it an ID, then it'll be able to match the ID to the particular tile and then return the correct tile that I'm looking for. Now we just need to do the public string get ID, return ID. That'll get that error to go away. We need public layer get layer, and then we're going to return layer, and then public image icon get image, and then we are going to say return image. Now remember, for the empty tile, image will be null, so when we go to render, we'll just check and see if it's empty, then we're going to know that there's not an image. Now we need to actually go ahead and define all of the constants that will go in here. So here's an environment, and I'm just going to do a couple of them for now, just for maybe, you know, in between this video and the next one, I'll finish defining the rest of them because it's not terribly important. It's just, you know, the particular points and what corresponds. So the first thing that we need to do is we need to declare the empty tile. Then we need to declare the grass tile, which the name will be G. It's going to be at position 1, 1, and it's going to be layer.below. So this, in this case, it actually does not start at 0. It will start at 1. So we have 1, 1, which is, you know, first tile by first tile right there. And it's in the below layer, and its ID is going to be grass. Then we can go ahead and define these two waters for now, and then I'll just do the rest outside of the video. So I like to organize these by the, I guess it would be the Y layer, so that so this contains everything from that first row, and then this area should contain everything from that second row. So this one we're going to call first water vertical, and this is going to be WV for water vertical. It's at position 1, 2, and then layer dot on. That's because it's on with the player, so the player can't actually go into it. Then next, in the next Y position down, the next row down, it's going to be water horizontal. Did I even spell that right? Horizontal. And that is going to be WH, and that's going to be at position 1, 3, and layer.on. So all I've done here is define the empty tile and then just 3 more tiles at the different positions. Each of them has their own ID and then the layer where they belong. So that's just the beginnings of the actual, you know, tile thing right there. So the next thing that we need to do, and we're starting to run out of time. I might, you know, go a little bit over just to, you know, try to get a little bit more done. But we're going to go ahead and actually start on the map. This is pretty much everything that we're going to need to do for the tile. There are a couple of other things that we'll do eventually, but for now we're going to start the map, where you can actually define maps and then write, and then, you know, load them in, parse them, and understand exactly what you're trying to do. So let's go ahead and make the new package called map, and then we're going to have the Java class called map, which is going to represent a map. Then we need another class called map manager. This map manager is going to basically contain all of our maps and provide the ability to get a map by a name, and, you know, get all of the other information from there. We also need to define a couple of other things. Map type, which is actually going to be an enumerator, and this is basically all the map type does is it controls what background is painted. So if we're in, like, you know, an outside map, then it'll automatically fill everything with grass before it continues through and you know, puts everything on top of it. If it's inside, maybe it would fill it with, like, you know, wood or whatever other tile we would want. And let's just go ahead and quickly do this. It's just going to have a private tile, private map type tile. Make sure to import that. This dot tile is equal to tile, and then the public tile get tile return tile. This would be like if you had more than one, and, you know, any good game would have, you know, some indoor, some outdoor. Maybe you would, like, go exploring in a cave, or, you know, various different terrains, and then this would basically control what's automatically painted in the background. Alright, so let's just go ahead and define one called outside, which takes tile.grass. To iBenja HD, I'm not completely sure what you mean by do the live stream bigger. If you mean quality, I have it uploading in all of the possible qualities, but if it's not looking great, then that might just be because I only have so much bandwidth and it might not be working. Can I make it randomly generated? You could, and you could write that. For now, we're going to have it load in map information, and it's not going to be randomly generated, but yes, you could make it randomly generate. You would, of course, want to write an algorithm so that you didn't have, like, random, you know, like, water, and then right next to the water is, like, a fence corner with no other fence near it. So you would have to write an algorithm, but it wouldn't be that hard given the solid, framework that we've already written. So that's just map type, which we needed to write. Let's go ahead and write we're going to write the structure of the map class right now, and then tomorrow we're going to actually fill it in where it will read in all of the different maps, or we'll start with just one. It'll read it in and parse it. There's a couple other things we need to do, and then by tomorrow we should have it be able to render a map with all of the tiles that we specify, and then display the map. That should be pretty good. iBenja HD, as I said in the beginning, which you might not have been here, this is an RPG game. It's gonna look similar to Pokemon, so just where you have, you know, a 15 by 20, I believe, grid, or 20 by 15 grid of tiles, and then you have a player that can walk around on the tiles, interact with things, and then, you know, we'll have like a tile, like an event system. So if you walk to a specific tile, it'll do something, or if you interact with a specific tile, it will do something else. So that's basically what the game's going to be. And as I said before, it's not going to turn out to be like this whole ginormous, amazing game, because we don't have that much time. It's really going to be more of a solid outline or framework of the game, which you guys can then take and adapt as you want. But it's also just to show, first of all, a different look at all of the stuff that we normally do. This is completely different, and it's also just kind of to show the process of going through and making games, starting from the beginning, getting everything laid out, and all those cool things. So that's basically what this video is all about. So inside of the map, we're going to define a couple of things right now. We need to have a private array list row called rows, and then, not that row actually, we need to make our own row class, which I think we'll do here. The row class is basically, we're going to be organizing the tiles into, you know, rows and columns. So for now, I'm going to have a row class, which represents a row, and then method to get the tiles in each. It's basically the same thing as using a two-dimensional array, but when you start getting to like a huge project, and you know, like you have a lot of if you start to get where you have a lot of tiles, and then it can get kind of confusing, like that. Alright, so we also need the private string names. We have the ability to access each map by its name. We need the private map type. That will just be the type, as I said before. And then we need a private location spawn. And this location is going to be yet another class that we're going to make. And this is basically going to represent a location on the board. It will have, you know, the tile of the location. It'll basically store, you know, what's on. So like if there's a player or an NPC on it or any other entity, it'll store the entity on it, and then some other information. So we need to know what the spawn is, so that if we go to spawn a player, then we will know where to put them. So we're going to go ahead and do our public map, which will take a string name. And in the map managers, we're going to instantiate all these in the map manager, where we'll know all of the names. But given the name, this is where we're basically going to read in map from text file, because the way that this is going to work is we're going to, in this resources folder, we're going to have a bunch of different text files. Each one is going to represent a map, and it's going to be written in a specific format. And given the name of the map, we're going to find that particular text file, read in from it, and then we're going to parse all of the information out of it, and then do that. And then let's just quickly go ahead and write the setters, or getters rather, return name, public map type, get type, and then return type. And then that is all that we're going to do for now, except we do, I guess we might as well do public location get spawn, return spawn. Alright, so that is all we're going to do for today. We're just a little bit over an hour, which is exactly what I wanted. It's the exact time frame that I wanted. Tomorrow we're going to actually write the constructor for map. We're going to write the map manager that will read in all of the different maps, then instantiate a map class for each one of them, and then so we can get that all set up, and then we'll actually write the GUI so that it will read through all the different tiles in the map and then draw each tile in the correct order so that we can actually tomorrow have a drawn map. Then after that we will work on, adding a player and getting the player to be able to move around and collision detection with other tiles that are on the same level, like water, and then of course the edges of the screen and lots of other things like that. To answer iBenja HD, this is not a Bucket plugin. This is written in Java. It's written in Swing, which is an API for Java that lets you display graphics. So as I showed you before, if I go ahead and run this right now, and I'm assuming that it's not going to give me any kind of an error, hoping, but you'll see that it actually pops up its own window. It's a standalone program. It has nothing to do with Minecraft, nothing to do with Bucket or anything. It's its own personal, standalone, completely different game. So as you can see, we just have this window, but tomorrow we're going to fill this window with the actual map. So it'll render each of the tiles from that environment tile sheet in the order that we tell it to, and then we'll add the player so you can walk around. This doesn't have anything to do with Minecraft. It's a completely separate game. So that's basically that. So that's all for today. This video will go up on YouTube right after I stop it, so that for those of you that want to watch it again, or for those of you that missed it, you can go to YouTube and watch the video, as I will do for each day. I'm going to figure out the issue with GitHub, and I will post or push the code up there. So if you're following along and you're interested in coding, or if you're interested in coding this, then you will of course have access to all of the code that we will be using. That is all for today, and I will see you guys at around 4 o'clock again tomorrow for the next part of the Game Jam. Thanks so much for tuning in, and I hope to see you all tomorrow.